Thank you very much. What a challenge to follow that lecture. Well, first of all, I've been asked to say a little bit something about Arup, because most people don't know that Sir Ove Arup, who started the firm in 1946, was in his 50s, and 30 years later, he turned the firm into a foundation. We are now people-owned, so the staff owns the firm, so that it's secured to the staff, and that no influence from the outside, which isn't desirable, would be able to take over. That creates a big independence, and for us the chance to do what we really want to do to shape a better world. I start with a little film to come to the subject today. In 2006, Germany had the World Football Championship. And shortly before the World Championship was kicking in, we have been approached by an agency who said the German government has decided that they want to promote during the football championship Germany as a country of inventors. Germany has had a lot of inventions over the centuries, and the idea was to actually promote this with a series of sculptures which are kind of generic but always hint to special products. And we've been told we've got 3 months to actually build these sculptures. And we thought 3 months is actually a little bit short in time to design all of that. And then they turned around and said, to build, not to design. They had to be in place 3 months after we have first met, and they were only in place for 3 months, so there was also an economic challenge because you just couldn't do what you normally might do for sculptures. And the idea was that these things couldn't be normally produced like you produce a design. We were not able to have foundations. Everything, because it was only up for 3 months, had to rest on the ground and be secure. Everything we wanted to use was actually material which was too expensive. So we had to come up with a solution, and it was very, very clear that a conventional way of working would not get us there. Also, the challenges that you have when you are designing digitally with authorities. Also the challenge when you're working with authorities and you have to come to use materials that haven't been used before. They challenge you with testing, proving. All of that process was something that was very, very difficult for us at the time. And with my background of having had an education as architect and later in Britain as membrane engineer, I knew from membrane structures that it was actually possible to do digital design and go with digital material directly into manufacturing and then to put it up. By the way, it's actually 25 years ago, 20 to 25 years ago, that I have been working and designing on this building. It's actually great to be back and to see it's still in very, very good shape. I've been designing the facade and the roofs when I worked for Octotube in the Netherlands. So I'm very proud to be here. Right. So I want to talk to you about the challenges which we had to focus. Chapter 1 was the design challenge of no time, no budget, no proper foundation to stand on. The research in methodology and in materiality was really overriding everything at that moment. We needed to find the right sort of material, and we have sort of looked at that in various ways. We first sort of looked at sculptures which could be traditionally be casted. But casting was far too expensive and far too time-consuming alone to build the forms, let alone then to cast and then to treat the sculptures. Then there was like sort of small machine components which could be together like sort of bricks almost, small steel components that would be interlocking. was not working, took far too long. And then we had this idea that if we were to take insulation foam, which we know from constructions, that's a very light material, it's a very cheap material, and it's one that can easily be formed. The question was, how would we give that then an appropriate outlook? And we have been testing various coatings with that, and I want to briefly take you through that. Glass fiber insulation, glass foam, could be coated with metal. Hot metal spray because it's temperature resistant. So we have tried that. We went to firms and we looked, but we had disappointing results. But after a certain while, the material actually started to peel off. And then we started to test how actually the digital information could be transformed and manufactured into these sculptures. We also had to test how much time it would take and how the result would come out. And what you see here is one of the wall plugs that you normally use when you drill a hole, you put the plug in and then you put your screw in. And that wall plug was one of the German inventions that was discussed as being one of these exhibited sculptures. And this film was just showing a first test how this with a 5-axis grinder could actually work and how long it would take. And this is sort of the real time that you are now seeing. So it's extremely fast how you can actually produce something like that. And it was flabbergasting even for me sort of to stand there, even though we have sort of designed it and worked around it. And there you go. I mean, it's very, very fast. The question just was, how do you take a foam block, which is supposed to stand up for 3 months, in the public realm that people would go to, climb on, lean against, all of that, where people might even put firecrackers on and stuff like that, that it doesn't catch fire. So we had a decision made. We are using CNC grinding because it's very fast. We then came up with the idea that we just put on glass fiber coating, put a mesh over it, glue it on, and then we apply a paste. The paste can then be grinded on so that it's a smooth surface, and then we use car industry spray to make sort of the same coating as you have it on cars. And the whole thing would then be installed in big chunks onto steel substructure, because steel is very heavy and it can rest on the ground, not necessarily needing foundations if the ground as such, a place, is sort of solid enough. So chapter 2 was to design individual sculptures. Well, with Scholz and Friends, the agency designing sort of the shapes as such, we went and started what it looks like. But it was clear that the process as such with hand sketches is not reliable enough, even though it was fast, but not reliable enough, not easy to communicate, and also with email not very easy to do. 3D modeling with workshops and video conferencing seemed to be the solution. So we looked at these methods and decided that that's what we do. But still, once in a while, we needed a hand sketch. It was not always perfect, but that's what also I would like to give you as a message. I'm not afraid to overpromise. We just heard that. Where is he sitting? Well, we just heard it. Overpromise a little bit and then deal with it as you go along. And that's what we've done. And we were able to go to chapter 3, material testing. So I mentioned it before. When you have a new process, you want a new approval process applied, and you come with new materials which haven't been tested in their combination and also in their safety, you actually need to go to authorities in Germany. That's Bundesanstalt für Materialprüfung, sort of a national institute of material testing. And they really make your life difficult, I tell you. And we've undergone very serious tests, and with all the things that we've been doing, in the end we were successful, sometimes with a bit primitive means, as you can see. Sometimes, you know, the last bit was some sort of sellotape strap or something like that to make things happen and work. Coming to chapter 4, which was a very, very good challenge to test reality now. The elements have been produced with the 5-ax grinder. The steel components have been produced to put it up. The paste has been with the 5-ax grinder instead of a grinder, then with a paste maker being applied. So it's always the same machine. It's the robotic arm with different tools at the end doing the whole work on the digital thing. There you can see sort of rollers which then sort of apply the paste. But again, human beings always have to make sure that the last sort of check is really working. And then the spray has been applied, again, automatically. Then the finished sculptures have been brought into their location and have been handed over. Aspirin tablet as an invention from the chemical industry, pharma industry. The book printing as a solution with a pile of books. The music industry with the invention of the digital CD. And last but not least, because the soccer event was, after all, a soccer event, the invention of the soccer shoe by the brothers Adidas and Puma. And what we've learned from that, even though it was sort of a small thing, sculptures, it does work, we can do it. Immediately, while I worked on a competition with UN studios for a project like that, where UN studios are very famous for the fact that they never do sort of repetitive things, but all their things are slightly variations, and that makes their great architecture. It was very clear to me very quickly, we need to apply things like that. And the first test was at our headquarters in London, where we've tested facade elements to be built with that methodology and to be applied. And from that moment onwards, the process in the firm was about making things more digital, making things more robotic, making them producible. Installation was sort of put together. And a few years back, we have built the first concrete house, which was printed, 3D printed with a robotic arm in Milano on the square in front of the dome. But what we've also learned is that not only production, also assembly can be dealt with robotics very, very fast. And all of that comes out of the digital design. And together with Zurich University, with the ETH, we have worked on these processes to develop different methodologies. But what we have learned is not only is sort of the construction itself and the production something that is undergoing sort of different ways of procurement, it's also that in the timber industry, which is an industry which is very, very receptive to digital design because all of the timber is being cut with CNC mills, they've taken it over and they have said, we can take over part of the execution drawings. The execution design is for us because we know how these things work and we put that together. And we realized with this project that we've done for refugee housing and student homes in Berlin, a first realization of not only 2D elements, but also 3D timber containers, and they came on site with fully furnished, finished rooms, which were just being stapled on top of each other and connected with the medias and then plug and play. So we realized that it's not only just the working drawings, but it's also to do with a performance specification rather than a specific and bespoke specification. And we realized that all of the digital process is shifting back into very early stage design, even back to the idea, because sometimes it's the idea that generates a different way of dealing with it. So in the end, the whole design process, we realized, very often now called BIM and all sorts of things, is shifting in different directions. The workload is shifting in different parts of the design process because a lot of the things you have to do much earlier now than you would have done historically. And last but not least, it all depends on having a big, big cloud accessible from various sort of people like the BIM coordinator, but also the designers on various ends, and then shifting it all to the construction companies who, with their own knowledge, then implement that to be built. and all without a single piece of paper being transported with drawings. And when you see the renderings and then the building, would you believe that this building is being built in less than 3 months on site? Construction site is costing you money, a lot of money. And the faster you can do that, the less workers you have on site, the higher the security, the less the risk, and the cheaper the result for the end user. And we see that with big components being produced in the factory and then being brought on site, and these sites go up with very, very few people on site very fast. The student building was also built within 3 months, 7,000 square meters. And this is one of the last sort of projects I want to show, much larger elements being produced and then being assembled on site. It's a dry construction. I'm almost done. And what I wanted to say is all of this process goes from the very big down to the very small, because we're now also able for bespoke solutions for the one single detail, or maybe a detail which changes gradually over the facade, to be produced digitally, and it's no difference in cost than producing the same thing all over. So variation is possible. We're working on Sagrada Familia and getting that finished with the digital process just as much as, for example, in Milano, the Zaha Hadid building, from very small to very big, from very old to very new, and it's only the sky that is the limit. Thank you very much.